we're going to use this formula and this known solution to find the second solution to this second order differential homogeneous equation. In this situation, the formula says to take a known solution and then integrate e to the negative integral p of x dx over y sub 1 squared, where this is a known solution squared. And this p of x is the function that would be in front of y prime. In our original function, there is no y prime, which amounts to saying that the function in front of y prime is 0. So once I start to plug things into the formula, I know the second solution will equal my known solution, sine of 3x, integral e to the negative integral of p of x, or e to the negative integral of 0 dx, known solution squared. And now we just have to go through and take care of all these calculations. Integral of 0 is going to be a constant. E to any constant is still going to be a constant. And since we're talking about just finding a linearly independent solution, we end up ignoring all these arbitrary constants. So my next line, if I was doing this, would be say, all this stuff is going to be a constant that would float out in front and then promptly be ignored. So I'll have sine of 3x times the integral of 1 over sine squared 3x dx. And this may look like kind of an intimidating integral until you realize that 1 over sine squared 3x is the same thing as the cosecant squared of 3x. And this is one of our basic trig integrals from BC Calc. It happens to be a derivative of negative cotangent of x. Now we have a 3x here, but you know, if we were to integrate that, it would just amount to having a 1/3 out in front, which is another arbitrary constant that I'm going to ignore. So after integrating this, all I really care about is the fact that this is negative, don't care about the negative, 1/3, don't care about the 1/3, cotangent of 3x, and the sine of 3x is still chilling out there, so it's still here. Cotangent, we know, is cosine of 3x over the sine of 3x. This sine of 3x is still here. These guys cancel. So my second solution would be of the form, some constant times cosine of 3x. That's it.